finds you well. Going through the problem of the week, I realized that I did not go over how to use the distance formula, which is probably the more difficult of the two techniques to understand. I'd argue this is the easier way to solve these most of the time because it does not require graph paper. And it essentially follows the same principles of the Pythagorean theorem, and it will work in any scenario. So there's a couple tricks to go over. So this is a distance formula. If you want to pause real quick and write it down, feel free. So let me explain it real quick. So D represents just simply the distance between 2 points. This right here is just a very large radical. So everything underneath the radical is going to be performed before we find the square root of those values. You'll notice that the x's are grouped together and the y's are grouped together. I'll talk in later when I do an example how does it really matter which one we call x2 and which one we call x1 and vice versa, as long as they're grouped together. Same thing with the y's. The one thing you want to make sure of, if you have a negative value and we put it in the position for x1 or y1, we want to make sure that we put that in parentheses because we're really subtracting a negative value, which would mean we're adding it. So just keep that in mind. That's probably the most common mistake students will make when using the distance formula is putting a negative value in incorrectly. So keep that in mind. All right, let's go ahead and look at an example. Okay, so for example, I'm going to look at, make sure my pen's working. Nope, there we go. Black, good. All right, we're going to look at the point 7, 8. And the point 10, 13, and we are going to use the distance formula, which is D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So the difference right here really represents how far we're going to the left or the right. So the horizontal change. This right here represents a vertical change. So this would be a leg of a right triangle. This would be the opposite leg of the right triangle. All right, so now technically speaking, the point which is further to the right would be the second point, and the point that's to the left would be the first one. So from a technical standpoint, this is x1, this is y1, this is x2, this is y2. Ultimately, it doesn't really matter. We'll get to that here in a minute, as I told you guys earlier. So let me go ahead and set this up. So D equals the square root of 10, x2, 10, minus 7 squared plus y2, which is in this case is 13, minus 8, which is y1 squared. All right, so now follow order of operations when simplifying the right side. So we're going to do everything underneath the radical sign before we go ahead and find the square root of that value. So 10 minus 7 is 3. So I have 3 squared plus 5 squared. 13 minus 8 is 5. 3 squared is 9. 5 squared is 25. All right, add those, find the sum of 9 and 25. We have 34. D equals. Now D is approximately 5.8. So the distance between 7, 8, and 10, 13 is approximately 5.8 units. All right, now I told you guys earlier that you could switch it and it doesn't really matter. Now the reason you can do that is because 10 minus 7 is 3. Negative 7 minus 10 is negative 3. 3 squared and negative 3 squared are both 9, which means since we're squaring these values right here, you're going to get the same positive answer regardless of which one you put in. So quickly, I'm going to do the same thing, use a different color so you can tell the difference. Same thing, but I'm going to switch the order that I put the x and y's in. So let's say I don't want to bother saying this one's the first point, this one's the second point, vice versa. I just want to put them in as I see them, which is how I usually do it. So it's 7 minus, oh, Mr. Robinson made a mistake. It'd be 7 minus 10. I just modeled another mistake students will often make. They'll put the points next to each other as opposed to the same variables. Squared plus 8 minus 13 squared. All right, d equals square root, so this would be -3. This would be -5. Okay, so as previously stated, when I square a negative value, I'm going to get a positive value, so this would be 9, and this would be 25 again. So as you see here, they are the same. Square root of 34, d equals 5.8 units. Okay, so that is an example of how to use the distance formula to find the distance between 2 points. Generally speaking, I think if you have graph paper and the points will fit on the graph paper, it's pretty efficient to just go ahead and use the Pythagorean theorem and make a right triangle. If you don't, the distance formula is going to work regardless of the points you're using. So a couple things to think about. First off, make sure you're using pairing the x's with the x's and the y's with the y's. Other than like the negative value mistake, the next most common thing is the same one I kind of started to make earlier before I caught it. Your students will simply put one coordinate together and then the other coordinate together. That doesn't really do us any good. So make sure you're pairing the x's with the x's and the y's with the y's. When you get to this step right here, after you square those values, they should all be positive. So if you see a negative value here before you find the sum, you made a mistake. So think about what you did wrong, and chances are you just need to make it positive. All right, if you guys have any questions, Olson and I are available. Send us an email. We'd be happy to help you out. I hope everyone's doing well. Thank you.